Okay, so this is problem 67 for chapter 4. And so what it says is researchers have measured the acceleration of racing greyhounds as a function of their speed. A simplified version of the results is shown in the figure P 4.67 below. The acceleration at low speeds is constant and is limited by the fact that any greater acceleration would result in the dog pitching forward because of the force acting on its hind legs during its power stroke. At higher speeds, the dog's acceleration is limited by the maximum power its muscles can provide. So A asks, what is the agent of the force that causes the dog to accelerate? And so, interestingly enough, this is actually static friction of the ground on the greyhound's feet. And so it's actually, the dog is pushing against the ground, and that's actually going in like the negative x direction, and so then that static friction is actually pushing it in the positive x direction, so that's what's causing it to move forwards, which is really interesting. And then B, it asks, if the dog's mass is 32 kilograms, what is the average force acting on it during its initial acceleration phase? And if you do look at the diagram that they have provided in figure P 4.67, you see in the graph that that initial acceleration is 10 meters per second squared. So that's what we're looking at. And so all it is force equals mass times acceleration. So 32 kilograms times 10 meters per second squared, that equals 320 newtons. Okay, then for C, what it's asking is how far does the dog run in the first 4 seconds? So again, if you're looking at that diagram, you see that in those first 4 seconds, the acceleration stays constant at 10 meters per second squared. So we can use that kinetic equation, but all we're looking at, because our initial velocity is 0, so that whole equation is delta x equals initial velocity times time plus 1/2 a times delta t squared. So again, there's no initial velocity, so we are just looking at delta x equals 1/2 a times delta t squared, which so when we multiply all that out, we end up getting 80 meters. And that's it.